Good afternoon. I'm George Leopold, the Global News Director with EE Times. You're at the Smart Grid panel, deploying the U.S. Smart Grid. We got a real good panel here, a lot of smart people from across the energy industry and a regulator as well. As with all of our panels, we invite your questions. Just step up to the mic and we'll get in as many questions today as we possibly can. So we're going to start by doing a quick introduction from each of our panel members, just a short synopsis of what they're doing and how it fits into this overall smart grid effort. Mike, can we start with you? Mike Fuller from Cisco Systems. Introduce yourself. Tell us what you're doing.
So Mike Fuller, I'm a Manager of Business Development for Cisco's Smart Grid business unit. I've been working on Smart Grid at Cisco for 3 years now on the product development side and now in business development. We've just recently, in the last 8 to 10 months, formed an official BU at Cisco to focus on this, and we think there's a large opportunity in what's happening in the utility space related to IT and technology being integrated into the power utility grid. And we are looking at it obviously from a communication standpoint, end to end, and bringing a lot of what we've learned in other industries related to IP and communications over to the utility space and helping through this transition.
Okay, thank you. Chris Knudson from PG&E.
I'm Chris Knudson. I am Director of our Technology Innovation Center within PG&E. In the capacity of that organization, I guess the simplest terms is I make things work for the first time. To get a little more specific, I have 3 dimensions. One is labs. So we work with vendors and partners to take emerging technologies into labs and to evolve them to a point where we can move them over to our production systems and development teams. I have a systems engineering view where we look at analytics and simulations and the impact and modeling of these technologies as they go into our system so we can understand and really quantify the problems. And then I lead our industry standards efforts, which work closely with George and all of the effort that NIST is leading to help define the standards that then map back to the technologies we're implementing. And then in parallel to that, I also lead our overall smart grid architecture effort, which is defining end-to-end how all these systems fit and how we map and develop an architecture to deploy them, looking forward.
Okay, thanks, Chris. George Arnold from the National Institute of Standards and Technology.
Thanks, George. I've been with NIST about 3 years. Prior to that, I spent over 30 years in the telecom and IT industry and have lived through several generations of transformation of telecom networks to IP networks and so forth. A year ago, I was asked to lead our efforts to coordinate the development of a standards framework for the smart grid. Working with industry and many associations and other government agencies. It's fairly unusual in this country for the government to play that role, but Congress recognized that to modernize the electric grid, which is really one of the most complex infrastructures ever built, it was going to take a strong standards foundation. And given the number of players in the industry, we've got 3,100 electric utilities, hundreds, probably thousands of suppliers. For all this to work together and evolve over time to meet new requirements and incorporate new technologies, the standards were critical. So that's why my agency was asked by Congress to play that role.
Thanks, George. And lastly, Catherine Hamilton, who ran all the way here from Washington, D.C. this morning.
Kind of felt that way on a middle seat. I'm from GridWise Alliance, and the Alliance is a group of 140 companies, a coalition working on consensus basis all along the grid, very holistically, technology neutral, to try to advocate for a smarter grid for the public good. We have everybody from utilities and independent system operators to research organizations and universities to telecom, IT, manufacturers, VCs, building sector, transportation sector. So it's trying to come to consensus on really big policy initiatives for smart grid, and that includes advocating for the stimulus funds, which we were happily able to get billions of dollars for that for smart grid, then advocating for them not to tax those stimulus funds, which we also advocated for, and now we're advocating for yet more stimulus funds in the jobs bill. So hopefully that will all come to pass. And we also do a lot of other kind of deeper work and thought around how do you construct a policy that really moves the industry forward, that changes regulation, evolves regulation, and evolves the utility business model. And we're really supportive of the NIST efforts as well.
Okay. So I'm sure we'll get back to how some of that stimulus funding is being invested. But first, let's start with where we stand in terms of the standards efforts surrounding this. George, if you wanted to sort of give us an idea of what the main issues are and where we are in the process.
Okay, well, if you go back to the Energy Independence and Security Act, which Congress passed in 2007, it's really a very important piece of legislation. We're probably the only country in the world that has a national law that lays out a policy, national policy for the smart grid. And it lays out 10 points that describe the characteristics that were envisioned, things like integration of distributed renewable resources, consumers having access to real-time data on their energy use, and so forth. We have worked over the last year with literally hundreds of companies, nearly 2,000 people in mainly industry, to work through high-level architectures, look at use cases, identify the types of standards that are needed, examine where there are existing standards that could be applied and where there were gaps. And the culmination of that effort was a document that we published in January of this year that we're calling a Release 1.0 framework for the smart grid. And I would characterize it as, if I draw an analogy to buildings, it's sort of like an artist's rendition as opposed to an engineering drawing for the smart grid. It's fairly high level. There are a lot of issues to be worked. We have 16 action plans that are focused on filling gaps in the standards portfolio. One hot topic today is something the White House is very interested in, which is a data standard where consumers can get access on real-time or non-real-time basis to their energy usage, and that's a hot issue that's being worked. There are other issues like coming up with an approach, cost-effective approach for white goods appliances to interact with the grid. There are a lot of standards issues that have been pretty much resolved. I mean, we know where some of the the metering standards are coming from.
Okay.
There's standards for interconnecting distributed resources into the grid. So that framework you can download from the NIST website, and it's fairly readable. Going forward, there's a myriad of things to be worked. We've set up a new organization called the Smart Grid Interoperability Panel. Any organization that has a stake in the smart grid can join. There's no cost to join. And that's sort of the organization that's guiding this standards coordination activity going forward. There are some very high-powered people in that panel. Vince Cerf is a member of the governing board. So we're benefiting to a large degree from the experience gained in the last few decades on the evolution of the internet and trying to apply lessons learned there to the smart grid.
Okay. You mentioned that we do have some standards coming for things like smart meters. There have been some reports in the press that this was sort of a vulnerability, a potential vulnerability in a smart grid. Chris and Mike, maybe you want to address some of the security issues and whether some of these reports might be a bit alarmist, and how you're generally approaching it as you build the architectures.
Go ahead. Okay. I think, I'll characterize this, at the high level. I was an embedded system designer, started with RF design and was designing systems, and 20 years ago, the mantra was design for manufacture, design for test. I think today, in all of the efforts, both in the standards, in our practice in the industry, we design for security as a priority. So there definitely are a lot of reports, a lot of them anecdotal, about vulnerabilities that could or can be exploited. But when you put a layered security approach with policy, perimeter, physical, cyber together, and you follow best practices, you are doing exactly that. You're following the best robust practices, and you do that with continued testing, continued evolution. It's not the design is done and I've met my security requirements. This is a constant watch on the security, a constant building of the processes, the tools, and the systems to monitor for abnormal actions, constantly probing and testing as the environment evolves. So I am very confident in the fact that we are following best practices and continue to do so, and that it is a priority in the process, and that is the best we can do.
Okay.
So
Okay.
I don't know what more to say on it,
Okay.
other than give you that perspective.
Okay, Mike, you
Yeah.
want to address that?
Yeah, from a vendor standpoint, and at Cisco, obviously, security is something we focus on and have been very successful in over the years. And, as Chris says, I think we're moving down the right path. There's going to be, news in the industry, any new industry where you're going into doing something new with technology and vulnerabilities exposed. But it's not anything new that we haven't seen before. It's just applying those frameworks and lessons learned that we've done in other industries applied here based on the nuances of the solutions or applications or the environment that you're dealing with. And in smart grid, there is a lot of scale involved. There's, actually deploying equipment out in the field where you have, it's basically exposed to being tampered with. But we've done this before in, service provider space as well. And I think it's really just about adapting some of the frameworks and things lessons learned over the years to this space. And you see a lot of coordination between, folks like George at NIST thinking about this, and vendors like Cisco and utility partners like PG&E and Chris really getting together. And I'm really impressed with the collaboration you've seen across the industry to tackle these kind of issues. And we're very confident that we'll quickly move forward in this space regarding security and the other challenges we face.
Okay. So do you think, does the panel think that we're doing enough at this point to harden the smart grid? If I can use that term.
Yeah, I would say certainly we are. I think it is a constant exercise of diligence and making sure that we are applying best practices. So from PG&E's perspective, I feel confident that we are. And I also see it as a priority topic across the industry. There's the NIST security working group is probably the largest with 400, I think, participants, engaged in defining common standards and bringing up all of these issues so that we actually get a very broad, comprehensive view of how to resolve them, manage them, and design our systems to be robust relative to security.
Okay.
Yeah, if I could just add an additional point. We do have, I would say, the best minds in the world at work on understanding at a very detailed level what the threats and vulnerabilities, countermeasures, and so I think we have a high priority on designing how to protect the grid. Mm-hmm. The problem that I see is that it's not just a matter of designing the equipment. That's the easy part. There are a lot of, let me say, operational aspects to security that have to be embedded in management systems and just day-to-day operations. And with 3,100 utilities in the U.S., if you can imagine the number of network security people that would be required to support really, at an operational level, I think that's where the gap is. So that's the bad news. The good news is this is a great opportunity for jobs. And in a very hot area.
Mm-hmm. Mm-hmm. Kathy, can you talk a little bit about where the money's being spent and give us some sense as to what we're going to get for the investment?
That's the big question. There are projects in every single state. Most of them are moving forward now. Most of them are also very collaborative in nature and much more than just meters. They're very holistic. Many of them are end-to-end projects that really look at the entire system, the entire utility structure. I think we're going to see a variety of outcomes. You want everybody to be successful. That's not possible. But if you're not completely 100% successful, then what can you learn from it? And then how can you move forward? I think one of the key things about the stimulus funding is that it's really almost proof of concept for state regulators that you can do this and that there are benefits. And state regulators are in this interesting position of, okay, so some of it's funded by the Fed, some of it's funded by the state, so we don't have to take as big a risk with our consumer base. But we also have to figure out how to calculate investment over time for benefits over time, some of which we don't even know yet because we don't really understand how the consumer is going to engage in this. So it sort of requires a different thought process, and that's one of the things we're kind of trying to get our arms around is how do you help regulators understand that? How do you allow them to work within their construct in the regulatory structure they have, and yet with new and different ways? And I think these stimulus funds are going to help us figure that out and give us a great opportunity to do that.
Okay. Chris, can you talk about, we're sort of in the ground zero for rolling out these types of technologies. In this state, they're talking about putting in all kinds of electric vehicle charging stations over the next couple of years. I think the number was like 8 million someone's projecting. So how do you mesh all of that stuff into the grid, and how do you manage the loads when you're getting power from all kinds of different sources now?
Yeah, so a very complex problem. I'll try to simplify the answer. I think there's two dimensions to the answer. I think the first one is you really have to take the time to understand and quantify the problem. So that's disciplined system engineering design and disciplined system architecture. So we're doing that. We go through and in a very structured way, understand what the use cases are that drive the requirements, both functional and non-functional, from the application layer or just from the communication, latency, transport, capacity layer. From that, we define solutions. We work in parallel with standards to help feed that input into the requirements of the standards, and as well as listen to what other industry stakeholders, both utility and vendor partner, are doing in the same vein. That produces an initial architecture design concept. Then we take, from PG&E's perspective, we will work in our labs to deploy those in an environment that can support the risk. So we have operational systems outside our firewall. We have a lab that includes a complete substation. So we will test this functionality and validate our architectural premise in actual lab implementations. And then that will take us to another level of confidence. It'll de-risk the solutions. And then we will very carefully scale that into pilots. And you evolve the solution, so by the time you actually scale this to a large size, you've got a high level of confidence in the reliability and safety of that system. I think you asked us specifically about the vehicles, about photovoltaics coming on.
Yeah, it seems like that's a good example of something that's
those are two very real near-term systems that are going to affect the grid in a way that it hasn't been affected in the past. So one vehicle can represent a load equal to an entire home, and many of the homes were traditionally sized for one air conditioner or less than one air conditioner load, especially in regions that are close to the coast. Like Berkeley is a very good example, right? So that the transformer sizing is small relative to the load of the vehicle. So we're going to attack that problem on multiple fronts. One is to work in standards and communication protocols and eventually structuring rate structures to motivate individuals to charge at night. So we try to shift as much of the loads to off-peak time as possible. And then also looking very carefully at our infrastructure and deciding how we can deploy capital to improve the infrastructure to support greater load where we feel that shifting or the technology won't change. That's one example. Photovoltaics is another area that will significantly impact the grid. You've got a larger and larger percentage of distributed generation now trying to push power up into a system that was not designed to do so. And you have specifications around the inverters, the devices that translate the DC power generated by the photovoltaics into AC power into the grid, which are very minimal in functionality. Right now they basically say if the voltage exceeds a certain level, you shut off. If the power goes down, you shut off. There's a lot of work in the industry to define a more rich interface, which would actually allow those those photovoltaic generators to produce reactive power instead, to regulate their voltage, and to understand the needs of the distribution system, so to communicate with that system or the utility system so that you could actually optimize and balance the load. Even further on, there's the potential for these distributed elements, whether they're photovoltaics or whether they're an air conditioner that you could shut off, to have monetary value to help balance the load, to be bid back in. I mean, these are even more far-reaching concepts, but these are all concepts we're exploring in the design efforts that we're undertaking, across the industry and very much in the discussions around all of the NIST standards working groups.
Mike, how do you guys work with, are you doing any specific work with PG&E or other utilities?
Related to electric vehicles?
Yeah, well,
Or distributed generation?
yeah, smart grid in general, or any
Yeah.
specific projects that you're working on, network, wireless networking, for example.
You may want to, the communications fabric and how you communicate all this stuff together is key to that, and I think that's
Yeah.
Yeah, I mean, we're working with a number of the industry-leading utilities like PG&E, and really how Chris defined it, exactly what they're doing on the electrical network side. We're doing the same thing on the technology or communication side, and that is, mapping out the use cases in partnership with our utility customers, understanding what those use cases are, functional requirements, and also the communications requirements for those use cases, the economic requirements, because you're doing it this is such a scale, and as well as the manageability, security, and just the lifetime of these solutions. This isn't something the utility is going to roll out, a electric vehicle solution that they're going to refresh the entire thing in a couple of years. I mean, they need this to have longevity to make the business cases work, and so it's a little bit of a new challenge. But we're looking at this very similarly as Chris described on the technology side, and helping map out what those use cases are and all those requirements are, and then take and design the technology or communications infrastructure to map to those, and then, much as Chris described, pilot test and really work with the standards bodies, et cetera, to move this into something that can be rolled out in a larger scale, as well as with what Catherine's doing in the policy side, to let the regulators understand what the value is to the end customers, what the value is to society as a whole, and how we might move forward together on this.
All right. Again, anybody has a question, step up to the mic. Ma'am, please.
Hi,
Can you identify
This
yourself?
is good. Yes, this is Sarah Biabani. I'm working with IEEE 2030 standards to look at some of the architecture issues. And one of the things, we're really glad that Dr. Arnold's looking at, and NIST is looking at all the different standards. And I think a lot of what Chris and Mike have been talking about is dictated by standards in order to have all of these different utilities and companies interoperate. The question I have is, we're working really hard to define an architecture within the guidelines that we're looking. And what is your expectation in NIST? I mean, we don't want to have a disjoint architecture across various standards. So what is the expectation going forward? That how will we pull it all together? Does that make sense? It's a very difficult thing to do.
It is, and I think we're pulling it all together through the community that we've established, and this new organization that I referred to, the Smart Grid Interoperability Panel. It has an architecture committee that's been set up. It's a fairly large committee, and it involves people from the utilities. Cisco is on it. I mean, we've got all the right minds there, but we're really looking at that as the sort of the pinnacle place at which the thinking about the overall architecture is occurring, and we sort of see that sort of diffusing into the lower level efforts of projects like 2030, efforts in NEMA and other standards bodies. So what we call the SGIP, we see, at least in the U.S., as sort of the place where the high-level architecture is being discussed.
We'd like to kind of percolate the work we've been doing, because we've been working really hard to, in the trenches, especially for information technologies and interoperability, how we fit networks of networks together and servers and so forth. What should be the path to get our information percolated up, or should we just serve on the panel as well?
Serve on the panel. It's an open process. In addition to face-to-face meetings, everything is web-enabled, so we have a wiki in which discussions take place. Even the face-to-face meetings have web-based participation, so just join the party.
I can highlight here's a very specific example of work and how it's harmonizing some of these standards and interfaces across industry. So through the Smart Grid Architecture Committee, there's a conceptual architecture which is drilling down into a segmented conceptual architecture, which is moves into a reference architecture, and then I look at some of the work within OpenSG Communications, which is which has deliverables into Priority Action Plan 2 of NIST, which is really taking and detailing out the non-functional requirements across those interfaces, and that work is being contributed to by a vast number of entities within industry, both utilities and vendor. That specific artifact is highly beneficial to my internal efforts on in our architecture, right? So, and that process kind of pulls the pieces together into a common approach. That's one of a very real example that's happening today that's providing value and harmonizing industry across these architectures and standards.
And we need to communicate because there's a lot of work going on. We just need to synergize that. Great, thank you.
Okay. Anybody else on the panel on that question? Okay. Rick, go ahead. You're up.
Rick Merritt from EE Times. 2 questions, if I may. One for George. Could you give us just an update on how we're doing on getting to the point where we can plug that smart meter into the smart appliances around the home? And then one maybe to share from both Michael and Chris. And let's talk about the wealth of communications equipment that we have out there, switchers and routers and so forth. Well, what's going to have to be different about those systems for the grid? How would they look different? So, George, and then you go.
Well, on that issue of the appliances, I mean, it's not just communicating with the smart meter, because the smart meter is just one of several possibilities in terms of customer interface to the grid. But we've had a task group of the Smart Grid Interoperability Panel Governing Board that has been focused on this. The task force is led by Brian Markwalter, who's VP of the Consumer Electronics Association. And they're making some really good progress. I mean, this is a hard issue to think through, because you want to be able to support innovation and evolution of technology and customer choice. At the same time, you also want to deal with a simple situation where somebody wants to buy an appliance at Lowe's, bring it home, plug it in, and not have to worry about the networking, and by the way, move it from California to Chicago if they move, and it'll work there too. So it's a complicated problem, but this task force is making some very good progress in understanding the issues and thinking about a practical approach to dealing with this. So I would say just stay tuned. It's going to be reporting out its work to the SGIP governing board at its May meeting, and there may be some discussion on it at Connectivity Week in Santa Clara.
Okay. Anyone else on that one? Sir? Oh.
You want to take the start? Or?
Sure. Yeah, I can give you some specific challenges, and I can let Chris take over. Some of the challenges we're dealing with in smart grid related to the communications is that this technology is going to be deployed, outside the data centers, outside the control centers, and things that we're used to deploying IT equipment. So, from a vendor standpoint, it's really a challenge to understand, what are the requirements for, if I'm going to deploy a router out on a pole that's got to sit there for 15 years and it costs Chris a lot of money to send a guy out there to go climb up a pole that's dangerous to touch it. This thing's got to basically be plug and play, and it's got to be able to have a life longevity and be able to sit out there and be reliable. So it's very much a hardware and challenge for us from the IT space. Other things that's also a security challenge, right? So now these devices are being deployed all over the grid, where you have to assume that they can be breached. And in addition, you're dealing with folks that in a lot of cases might not be networking or IT savvy folks that are deploying these systems because of cost reasons and scale reasons. And you really have to build a lot of intelligence into these systems now so that they can be deployed quickly and be reliable and have a long life cycle so that the economics make sense. So just some specific examples from a vendor standpoint on some of the challenges at a really low level when it comes to these deploying these systems and designing these systems.
Yeah, I think the paradigm we're moving from is these legacy systems that are all very point-to-point, that have dedicated communication. The communication is not well integrated because you've had a history of system stacking up on system where we've got some 1,200 baud wireless links all the way to some that are tied by fiber, and migrating towards what I'm calling a communications fabric, which is a security-based, policy-based layers of security, and you will send the piece of information you want out into that fabric, and it will reliably get to the end device and in a secure way communicate performance action. That is the concept that we are going to evolve to over time, and we have to do that in a way that's robust, that creates products that are manageable and that last a long time. And that also has a methodology and a plan to integrate with all of our legacy systems over time at the pace that we can't afford to deploy capital to evolve that system.
Yeah, and to add to that, I mean, this is some of the things that Cisco sees as such exciting aspects of the smart grid area is that, really being able to build the intelligence into the communications network that can give Chris that reliability, that security, so that there's actually some knowledge in the communications network of what's actually happening in the grid, so it can recognize security issues. And in a time of a lot of times this system might not be under strain until an event happens, right? You got a major outage, a storm blows through, or a disaster. This is when the network's got to be able to jump into action and be intelligent about what's happening, what's the situational awareness, and how can Chris's operations stay up and running and get what they need out of the communications infrastructure in these times that are abnormal to the normal of operations in a normal day.
So it's got to be hardened not only for security, but from a physical sense.
Right, and then the intelligence has got to be built into it, as well as, we were hoping to design the network so that in these platform, as a platform, so that it really gets to that tipping point situation like we've seen in the internet or other spaces where, I know George likes to talk about, you probably couldn't imagine 15 years ago, what we're doing in the internet today, of being able to do things with YouTube, et cetera. Trying to develop the standards, develop the platforms so that vendors and other industry players can use that as a base of innovation to really hit that tipping point and allow us to realize all the different visions that we're talking about in smart grid. And Cisco's looking at that as really the network being something that's pervasive throughout the entire smart grid visions, and using that as the platform to allow for this innovation.
Okay. Sir. Is he on?
Hello. Yeah. My name is Nat Collins, unaffiliated. Much of UC San Diego is on its own mini smart grid, including all the communication aspects. Do small scale smart grids like that, do the four of you find those useful in your development for the nationwide smart grid?
There are certainly elements. I think there are a lot of localized, and smart grid is a very general term. When I think about smart grid, I think of generation to consumer at large scale, interacting in a way that's reliable, safe, and efficient. That's something we're barely starting to define the real problems that we have to solve or understand, and many of them we're not going to understand until we start getting these devices out into the edge. So you're going to get a large penetration of electric vehicles. You have a large penetration of photovoltaics. You start getting price-controlled thermostats, third parties driving business models to provide energy efficiency. All of these having some type of interaction and communication that impacts the load on the grid. And so we don't know those modes yet. So I think when you think of smart grid, I think that San Diego, for instance, a lot of value. The more information we can get, the better. But the big problem, the big picture, the big comprehensive system, we have a tremendous amount to learn. So it's only a small. I'm trying to say it's only a small piece, right? There's a very broad area that we still have to learn a lot and architect a reliable system around.
Catherine.
Yeah, one of the things I wanted to comment on is that we've been talking about this very complex and dangerous system, a grid overlaid with communication technology, IT, link it with transportation. There's one element we're kind of missing here, and that's the consumer. And that is the big kahuna, if that's what we're talking about. If we're talking about people trying to interact with the grid, what does that mean? And we need to do a lot better job about finding out what that is. How consumers behave, how they make decisions, what do they do when you give them information? Do they make decisions only based on price? Do they also make decisions based on values? Right now, people don't understand the value of electricity. They don't understand all that stuff you have to do, Chris, to deliver them what they flip their light switch on to get. So I think we also need to do a much better job of making sure we engage the consumer, that we understand the consumer, that we make things very simple for the consumer, and that it's accessible to everyone, that it's not just for people who have iPhones, who can press an application from their beamer to heat up their hot tub. That's not what Smart Grid is. It's being able to let everybody participate in the grid and be part of this complex system that you're designing.
Yeah, and I think it's incumbent upon this industry to begin to understand, now that we're talking about a commodity, and that's a very different model for the
Consumers do not
electronics.
understand that it's a commodity.
Yeah, yeah. Sir?
Vijay Parmar, I used to be with a company called Gainspan Corporation. This is a low-power Wi-Fi chip company that played a role in bringing Wi-Fi to the forefront of smart grid and smart energy activities. Right now, I'm with a small software company. Leading from your comment, what portion of the investment that is going into this is justified based on just benefits from the grid versus benefits from changes in consumer behavior? So that's number one, because some of us believe that it's at least not predictable in terms of what benefits we will get from consumers actually changing their behavior. Number two is inside the home, clearly the utilities are trying to drive certain devices and interfaces inside the home. There are companies like Google taking a slightly different approach, and now you have the large appliance companies coming in and sort of staking their own ground in terms of how they want their devices to connect to the network. How does that all impact what you're doing in Smart Grid Forum?
I think on benefits, I think most of what PUCs understand are, and have been able to understand, are operational benefits that benefit the consumer, not how consumers engage to benefit yet. I don't know that we have that information yet. That's still a little bit of a moving target. I know there's a utility, not you. There's another utility in the country that went before their PUC after they got a DOE stimulus grant, and the PUC said, how will this benefit the consumer? And they could not articulate it because they literally did not know how the consumer was going to engage. But I think it's going to have a lot of different models, and there are a lot of different ways we can do it. You can do it through the meter, or you could do it through a home energy management system. I think there are a lot of different innovations out there, different technologies. We're really technology neutral and platform neutral, so we want everybody to be able to kind of compete and see where the market goes, see what people adopt, who's going to buy the EV, who's going to buy the smart appliance, and kind of let all flowers bloom in the space, because it really is an exciting space right now.
If I could just add to that and address the second part of the question. What we're trying to do with the architecture and the standards framework is encourage the development of an ecosystem where you can have a variety of approaches, some customers will opt for programs that are very sort of, let me say, utility centric, kind of like the programs we have today with demand response. There are other approaches that involve a more let me say stochastic process where you put out price signals, and appliances are programmed to react to that based on customer preferences. So we don't know which is going to be the predominant mode. It's probably going to be many of these things, and the key is to have an ecosystem like we have with the internet that's standards based, that allows innovation and competition in a variety of approaches on these capabilities.
And I think an an important thing to understand is, so I came from internet high-tech background and was recruited into the utility space to drive the function I lead now, but I didn't really understand the economic model of how the utilities deploy technology until I was in, and I think that's a very important thing to understand, because it's very different than let's say your traditional business or company. Utilities deploy technology at the pace of value, and through our regulatory structure there has to be a business case where the benefit exceeds the cost of that technology. So we can't go deploy a technology until there is a case that drives value. And the methodology that I discussed earlier around how we go through labs and pilots, part of that is to understand that value and work with our partners in industry as well as our regulatory bodies to help communicate that. And when you understand that, that is what drives scale and deployment of these technologies.
Sir?
Hi, I'm George McCollister. I'm with Novatech. I'm a lead software developer and a security specialist. I was just wondering if you thought the extension of the utility communications network out to the customer, if that presented a attack avenue to the distribution and transmission critical assets, and if you think that small electric utilities and investor-owned utilities are ready to deal with that potential risk, and the risk there that even a couple of successful attacks could lead to a cascaded blackout sort of situation.
Yeah. I think my earlier comments about applying best practices in system architecture and design and segmenting areas of communication, policy-based controls, you apply best practices, much like financial institutions apply security mechanisms. I mean, that's the key, right? You can certainly put a system out there that has security issues, but it is the burden of the industry and the utilities to make sure we do follow best practices, and I feel that we do that in our organization structure and policy.
Okay.
Just if I could add to that,
please.
as part of our Smart Grid Interoperability panel, we also have a cybersecurity working group, which has over 400 people, mostly from private sector involved, and this is one of the many vulnerabilities that they're well aware of and are looking at very, very seriously. So the problem is understood, and we've got the best minds in the world thinking about how to address it.
George, can you talk quickly about how NIST interacts with DOE on some of these issues?
Sure.
We'll get to these other questions.
The Energy Independence and Security Act that I mentioned earlier really defines the roles of the different federal agencies on the smart grid. So Department of Energy has the overall responsibility for coordinating federal activities and administering the grants that Catherine spoke about earlier. It directs NIST to coordinate the development of the standards, and it directs the Federal Energy Regulatory Commission to adopt regulations based on those standards.
Okay.
So we work very closely, the three agencies, along with several other agencies. The FCC plays a big part.
Yeah.
If you read the National Broadband Plan, it's got a section on the smart grid, and there are other agencies as well. That's all coordinated through something called the Smart Grid Task Force. And so we're I'd say, well coordinated at the federal level under the leadership of the Department of Energy.
Okay. Sir?
Yes, Joe Wilson, USG. He sort of took some of my thunder because I was going to ask if you were engaged with like PNNL or Idaho National Lab with regards to security issues, and it sounds like, I guess you are. With regards to Mike with Cisco, I was wondering, you were thinking about differently in that kind of deployment space. Since it has to be ruggedized, maybe the military standards, because they have to be pretty ruggedized and pretty reliable, and maybe that might be a way to start. Just an idea. I don't know. Maybe you guys have already thought about that.
Yeah, I mean, that's an element. It doesn't solve the problem completely, but yeah, I mean, there's mil-spec components, but it's really a system-wide because you have to deal with the environmental aspects, but also the challenges related to just the area it's being deployed. Is it being deployed in a substation, inside of a small space? Is it going to be out on a pole top somewhere, et cetera?
Right.
And then really the constraints of that system itself. It's not just about the components, but the entire thing. How's it going to work together, and how can you build it such that the reliability can last decades rather than years? So.
If I could just chime in on that.
Please.
One area where we do need some more, I'd say, technical work out of industry is in ruggedizing equipment to deal with electromagnetic events.
Yeah.
And one type of event that gets a lot of press is the possibility of EMP, so a suitcase nuclear weapon exploded high in the atmosphere, which, but that may be low probability, but solar activity is a huge problem. In 1988, solar storms caused some major damage to some electric systems. And while in the military, there are systems that are ruggedized to deal with EMP kinds of events. They're just not practical in terms of cost-effective application in this type of civilian infrastructure. And so we do need better designs, physical, electrical designs to withstand these strong electromagnetic fields. So that's certainly an area for innovation in the industry.
Okay.
Yep.
Yeah.
Okay, I want to give this gentleman a chance. We got time for one more question. Thanks.
Good planning that. Jim Buslup, Masco Corporation. I hear a lot of talk about shifting load to non-peak times. Is there anything in what you're doing that actually reduces the total thing toward reducing the total amount of power used? Because if you just shift it to later, you're still using the same amount, maybe more.
Yeah. When you think of the directives that we want to drive for energy efficiency, so one is efficiency. How do you use less energy? So applying technologies that use less energy. I think 10% of our capacity is only used for 51 hours of the year. I think that was a 2006 number, but that kind of number. So there's this huge opportunity to shave the peak off the load duration curve. So applying knowledge so that consumers and businesses are aware of when they're using energy that they don't, that opportunity exists. There's a great opportunity just to shave that peak. Moving or shifting is another great opportunity because there's tremendous that all that excess capacity exists. That 10%, that we're generating.
If you're just shaving that peak though, and just moving that demand to another time, you're still using the same total power.
No. What I'm trying to say is there's two dimensions, right? You build programs that actually say use less. So let's use less of that energy and capacity when we're using it. And then there's also programs to motivate a shift. So you want to go down both paths, right? And I think these are some of the things we have to discover. I think the human interaction, the human behavior, the business behaviors when you have more information, when we mature systems that can provide more automated control to better manage your energy usage, we'll discover what is it 5%, is it 20, 30% that we can move. There are a lot of studies out there, most of them fairly small in scale, that will range numbers anywhere from 15 to 35%, depending on which one you read. But I think that the fact is we still have a lot to learn. And I'll go back to the processes that I talked about earlier. We will discover them by going down those paths and maturing and optimizing the systems as we learn. As we mature the technology, we will learn more. We will be able to make more concrete statements and solidify the architecture that provides the real value.
Okay.
And just really quick to add on to that, so on the consumer side, there's a lot that is being done in the industry to allow consumers or enable them to reduce their energy usage. I think that's pretty widely known. But on the operational side as well, a lot of the use cases that utilities are presenting as part of smart grid in the distribution side is related to energy efficiency. I mean, there's a tremendous amount of line loss, power loss due to just getting the power from where you generate it to the consumer, and there's a lot of more advanced operations you can do once you have the systems in place to do them, to react, to allow for much more efficient delivery of the energy, which will have that use case alone have a huge impact on the amount of generated energy versus how much it actually reaches the end consumer. So there's a lot going on there in the energy efficiency side, not only on the consumer side, but also just more efficiency in the operations and delivery of the power.
Okay.
Well, this again is an understanding of how the model works. So number one, in California, utilities don't make any money on the sale of energy. It's a simple pass-through. So we make money on the capital we deploy to drive the directives of the Public Utility Commission, which is energy efficiency, renewable energy. So you have to understand that model, right? We don't. Some states are different, right? Certainly other states are different. They do make money on selling energy, but that's not the model we follow in California. It's a balance, yeah. There are costs to deploy the technology. That cost has to be balanced against, so you use less energy. There's going to be a technology cost associated with providing those energy efficiency systems. That all is part of the equation that drives the rate structure, which then goes to the consumers.
Yeah, I mean, and think about it this way too. Think you might need a intelligent infrastructure for electric vehicles, for instance, right? And it might require a communications infrastructure. And if you can justify that by using that same communications infrastructure for this line loss or more efficient optimization of delivery of energy, that justifies the rollout of the communication infrastructure they can use for electric vehicle enablement, and therefore there's no rate increase needed. That's some of the things that utilities are looking for. So passing that in essence is passing along to the customer by not increasing their rate.
Yeah, or avoiding having to build more power plants.
I'm afraid we have to pull the plug on our discussion. Thanks to everybody for coming. Thanks to our panel. Very informative. Thanks to Rick Merritt for helping set up this panel as well. Thanks for coming.